So let's take a look at measuring active noise cancellation headphones using the ZUMI instrument. First of all, we need to connect power. I'm going to use this power bank. It's plugged into the USB micro in the back, so we'll power that up and power on the unit. Now I have a couple of speakers and an amplifier for external noise. I'm running these in through a 3.5mm cable that plugs into the rear socket. So we'll plug that in. For the test profile, we'll provide that on as a file, put it onto an SD card. Just in the root directory, we'll plug the SD card in at the back. Then we can enter the menu by pressing enter. We'll choose select profile, then we'll choose load from SD. Now there are a few pre-built profiles, we don't need to look at those right now. We'll load from SD, and then we'll choose ANC.ini. Any file is the configuration file. That'll load that test profile, and the test profile is just for measuring ANC. No fancy bits in terms of auto tuning and so on. It's just a straight measurement. So we put the headphone on. We'll switch it off first. We do the off mode first. Put the headphone into position and start the test. Then we'll switch on the ANC, and we'll have our measurement. So we're looking at the spectrums of ANC off and ANC on for that series of tones. What we really want to see, and the next we'll use the down button to move through the graph pages, is the final ANC curve. And we can see left and right we have peaks of sort of 26 dB and 35 dB. Quite a big difference on this headphone, and you can notice it when you wear it. It's been opened and closed a few times, so one channel has lost its edge. So we can run that test again. We'll place the headphone on, try and get it reasonably well positioned with ANC off. The first sweep of tones is with ANC off. They'll give us the SPL or the signal level when ANC is switched off. Then we'll switch it on. We repeat the same set of tones, and we can compare the level between on and off as a function of frequency, going from low frequency up to high frequency. As with all active noise cancellation headsets, in the high frequency range it is essentially zero. There's no difference. It's all around the low frequency range where we get the active noise cancellation. One of the main questions is going to be, what do we do with our external noise source? What do we do with our speakers? Do we just put one speaker on either side and that's it? The short answer is yes. However, the position of the speakers is going to have an effect, especially for feed-forward active noise cancellation, which will be sensitive to the direction that sound is coming from and the dispersion of that sound. So we'll move the speakers in nice and close. We'll make a comparison. To do a comparison, we'll press this button, hold. That will keep this curve as a shadow line, and we can compare with our next measurement. Let's switch the ANC off, start the test. Switch it on, run the test again. Kind of similar, we see a little better, a little increase in the ANC. I guess it quite likes the sound field being nice and close like that. How about if we were to put the speakers in two odd positions and see what kind of an influence that has? Start with it off. Then we'll switch it on. Now we get more or less the same response. I guess we could try a few different things. Let's put both speakers on one side, and that should show quite a difference for this channel, because the sound field is coming around the head. It's not getting nice and directly into that feed-forward microphone. We'll switch it off, run the test, and switch it on. And yeah, we see a bit of movement. In fact, the peak shifted and things like that. These effects are just the real effect of how it responds to sound coming from different directions. So we'll put our speaker back where we started. As a general rule, two speakers either side in close proximity is a pretty good measurement. We can't expect to get an absolute perfect measurement no matter what we do. If it's in an anechoic room or a reverberation room, they will all have characteristics that will give a different type of response. If we want to compare headphones, we simply need to keep the speakers in a consistent position. So we'll do that. We'll run the test again. Switch on. And even that small variation in position has affected the way that the feed-forward microphones especially are picking up the sound and the effect that they're having. Just shuffle them a little bit and we'll run it again. And still fairly consistent in that position. So this headphone, the Bose headphone, is running roughly 30 dB peak on one side and 35 on the other side. The next question is how loud do we need that speaker sound to be? And in order to sort of figure that out, it needs to be basically loud enough that we're clear of our noise floor. So we have another graph page here, if I go down, which is called spectrum, and this will show us the raw spectrum, sound spectrum from the on and off modes. So what I'll do in order to see where our noise floor is I'll switch off the speaker signal, run the test, and we'll see what the background noise level is. Okay, so I actually have ANC on in that case. Switch it off, it doesn't matter. And okay, we've got a bit of margin. It's kind of 20 dB, at least 20 dB over the background noise level, and that's sufficient for us to get a good measurement. If we were to run the speakers too quietly, which we'll do, we'll turn the volume down on the speakers to a fairly low level and run the test. What I'll do is I'll store those background noise spectrums and run a kind of a gentle level. Okay, the passive is still clear of the noise, so we've got enough signal to get a good reading. However, with ANC off, we're starting to get very close to that noise floor. Let's reduce it a little bit further. And switch the ANC on. Now we're starting to touch into that noise, so we look at the ANC curve. It's still enough, it's still enough. We can go a little bit lower than that. Switch it off. I'll look at the spectrum again as I do this. We'll switch it on. And now we're right into the noise floor in that low frequency range. Let's take a look at the ANC curve. Well, it's still giving me a reasonable reading, although that peak is starting to get compressed, so it's hitting the noise floor and we can't see any less level than that. We can go a little lower still. Switch the ANC on. Yeah, now we've got such a low level that it can no longer discriminate the noise cancellation effect. So the on state is just hitting the noise floor, and so we're not able to see the full range. So we'll put our speaker level back up to a decent loudness. It doesn't need to be extremely loud in this case. With this type of a signal, we do get a very good signal to noise ratio. So we'll run it again. When we're working on this type of thing or measuring, we don't want to be exposed to extreme high levels, so it's nice to set it at a level that is just clear of the noise floor so we can get a good reading without punishing ourselves. And there we go, back to 35 and 30 for the peaks, so that looks pretty good. On the other side, if we set the noise level too high, we could possibly clip out those measurement microphones in the air, and we would have a similar effect. We'd be effectively compressing the apparent level of noise cancellation. We can just take a look at another product. Check if we have a battery. We do. We've got power. So we'll put that one onto the headset, onto the headstand with it switched off. Pop the cable out of the way and run the test. Try not to talk too much during the test, although this type of signal has a good noise immunity, so it won't make terribly much difference. And yes, I've measured this one before, and that is really what you get. It is really just maxing out at about 10 dB. Although the peak is a bit higher up in the spectrum, that's not really helpful. So the Bose, of course, has very good passive isolation too, so they're really just focused on those low frequencies. This possibly has less passive isolation. If we wanted to measure the passive isolation, we could of course do that. We'll switch the unit off. We'll measure with nothing in place. Then we'll put a headset on. So it's the same effective test as active noise cancellation. As passive, it's a comparison between, for passive it's a comparison between no headphone and a headphone in place. It's switched off, so it's only the passive effect. And we get that kind of curve. And yes, there is an enormous difference between left and right channels in this product, but it's a very low cost product. The Bose, we would expect, in fact we'll take it off to get a baseline, and we'll put this headset in place. And really substantially more, particularly in this mid-range. We may want to just check, in fact, how we're looking in terms of noise floor for this one. In fact, we need to switch that off for that. Okay, so we'll just get our noise floor curves. We'll set the hold on to that one. Well, I should turn it on, in fact. One thing to note, in fact, the red dots here show us that we're actually clipping without the headphone on, so that is going to also have the effect of compressing the apparent loudness. Let's back it off a little bit. I'll cancel that test by pressing the button again. That's better, we just avoided the clipping. So obviously the attenuation from having a headset on is relatively large, so we don't need much signal. And pretty good. Okay, we are seeing, we're still clear of the noise floor and we haven't clipped, so that's what we want to get. And okay, that looks better. And yeah, really good passive reduction effect. We'll do the same comparison again with this unit, now that we got the levels set up correctly. And particularly in this mid-range, there is in fact a gain from having the headset in place. It increases the noise rather than staying even or reducing it. That's a fairly common characteristic of these type of headsets.